Hi, this is Mr. Manley. In this video, we're going to look at absolute value inequality. And if you're looking at this video, presume that you have taken some algebra. And you know something like this, that the absolute value of x equals 5 means that x could equal 5, or x could equal the opposite of x could equal 5. So this is a way that we work with absolute value, could kind of say by definition. And there's a logic behind this as well, but I'm going to keep it pretty procedural here. So the x comes down, and then the opposite of x comes down. All right, so keep that in mind as I work here through this absolute value inequality. First off, before I use this idea of x and the opposite, I've got to isolate the absolute value. So I can't have this -1 sitting here. I'm going to have to add 1 to both sides. So I've got absolute value of, and that should not be a 5x. That should be a 5. 5 minus 2x is less than 3. So that's a mistake up here. All right, so that x should not be there. Go ahead and erase that. All right, so absolute value of 5 minus 2x minus 1 is less than 2. Add 1 to both sides, and I get this statement. Now, the first thing is that we can just remove, once we isolate the absolute value, we can just remove it. So I get 5 minus 2x less than 3. Okay? And then what was the other thing I did? I did the opposite. So I'm going to do the opposite of all of it. Look at how I put parentheses around it. The opposite of all of it is less than 3. Okay? All right. Now, I'm going to solve each of these pieces here. So for the first piece, I'm going to go minus 5 minus 5. That's negative 2x is less than negative 2. Divide by negative 2. All right, and again, if you've taken algebra, you know that when you have an inequality and you multiply or divide both sides by a negative, if you multiply or divide both sides by a negative, then you are going to switch the direction of the inequality. So when I divide by negative 2 here, this is going to become x greater than. So that, you see the inequality switch there. Okay? And then negative 2 over negative 2 is 1. All right. And just a comment on being a good student and taking notes. If you were taking notes on this from this video, or if you were taking notes and you had a teacher in class who was putting this on the board, you don't just copy down what is on the screen. You don't just copy down what is on the board. You listen for the instructor to highlight key points, or you notice things that you are afraid, well, maybe I will forget that. I better make a note of it so that I remember it. So for instance, here, I might be making an additional note and say, be sure to isolate absolute value. Okay? Here, I might say division by negative switches direction of absolute value. Oh, a lot of words there. But that's what good note-taking might require. It might require a little bit more effort, a little bit more writing. Okay? So I won't always do this if you are following along with my series of videos. I certainly don't always write everything out like that, but those are things that I said here that you should take notes on, probably. Okay, so let's continue. Where were we? We were on the left portion here. We were doing this. Now we need to do this over here. So let's go ahead and begin by simplifying the left side. So I'm going to distribute the negative like so. And then I'm going to add 5 to both sides. So I'll have 2x is less than 8 divided by 2 divided by 2. And that's x is less than 4. All right, now we need to put these two together. And there is something happening here. The absolute value is less than. All right. Well, what does that mean? If the absolute value is less than, something that you would have seen if you've studied my videos or looked at what I say about absolute values, that absolute value is about distance. That's a way of thinking about absolute value, that it has to do with distance. So what if I substitute that in here? The absolute value is less than. What if I say that the distance is less than? So there's a distance that is less than versus a distance that is more than, greater than. What would that do? If the distance is less than versus the distance is greater than. This might not be so easy for you to see. What if I do it with a number and I just go 2? And then I go 2. What would that look like? If the values of x is less than 2, that means, what did that mean about distance? It means it's a distance from 0 is less than 2 units. So I might be stacking on a lot for you here, but that's what a way of conceptualizing this, or a way of thinking about this, is that I want all values for x so that the distance from x to 0 is less than 2. So what is that going to look like? 0, I'm going to go 2 units this way. I'm going to go 2 units this way. And then what are all of the values that are less than 2 units? They're all in here. Don't want these two, so I'm going to open that. Put an open circle there. And then if they're greater than, if the distance is greater than, I'm going to go here and here. And those are going to be all the numbers that are more than 2 units from 0. Something about this is that I could convert it to, well, x is greater than -2 and x is less than 2. And then that would be combined into a single sentence like this. All right, so all of that goes together. And then here, I would say x is less than -2 or x is greater than 2. Now notice in this one I said and. In this one, I said or. Because the x's in here satisfy both. It's both less than 2 and it's greater than -2. X is up here is one or the other. It's either this one or that one. And then that's all we can do with that. We can't write another statement. There's not another form of that statement, and that's it. Okay. So that was quite a detour there. And the fact of the matter is that whenever absolute value is less than, I've got an and statement. And whenever absolute value is greater than, I've got an or statement. So let's go back over here. What happened? Absolute value less than. So these are linked by an and statement. What does it look like graphically? Could you take a moment and consider that? Think about that. What would that look like? This and statement here. This and statement here. Graphically, I would need x to be less than 1. Greater than 1. And then, say over here, 1, 2, 3, 4, maybe here. And I would have greater than and less than. So that'd be a way of showing it graphically. With the set builder notation, algebraically, I would write it like this. X is greater than 1, less than 4. Okay? So that should get you a start with absolute value inequality. There's more to do with it. Really, what's the more to do? We would want to look at all of the variations. So I would want to at least consider a couple more variations on this. If I change the direction of the sign, and also I'd want to look at these as well. What if I said less than or equal to, greater than or equal to? Okay, so I'm going to leave that for another video or for some classroom instruction if you're in my class. But that's a good introduction to absolute value inequality.